Okay, hi. Welcome back. This section is on linear functions and also the slope. And with the difference quotient, I kind of foreshadowed why is the slope thing so important? We're going to apply, eventually, maybe when we get to calculus, slope to pretty much any function, and we'll have to learn a whole new process. You spend a lot of time in calculus doing that. It's called the derivative, and so slope is really, 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 really important. It seems like one of those elementary things, like, ooh, I just learned this, in the beginning math classes, and then maybe I never use it again. But that's not true. Okay, the slope is it's a rate of change, and rate of changes are the language of the universe. Okay, so highly important, and we want to make sure everybody's on board with this material. So 1.4 is on linear functions and slope. Okay, so let me get the screen kind of opened up. There we go. Okay. So first, just defining slope of a line. Basically, when given 2 points, so given point x1, comma y1, and x2, comma y2, we can form this value called the slope, which is really just a measure of like an inclination, like a roof kind of. It doesn't have a large slope, Anyways, a slope, we'll call it m, and another way of writing it is change in y over change in x. So that triangle symbol is also the Greek letter delta, okay, but we use it for change. You're probably more familiar with rise over run. Okay. In this context, to find the slope, we would go y2 minus y1 all over x2 minus x1. Okay, so given these 2 points, x1, x2, and maybe some coordinates, y1, y2, this point is here and this point here, we can determine the slope of this line using this formula. Okay, so there's 4 main types of slopes or describers of a line, and there's the positive slope, so that's where your line is basically increasing everywhere. Okay, so slope greater than 0. There's the negative slope case, so that's basically where your line is decreasing everywhere. There's the slope equals 0 case, which is where your line is horizontal. And then there's the undefined case, where your slope is vertical, or where your line is vertical. So m is undefined. Okay, so the first couple problems, you'll want to just calculate slopes given ordered pairs on a line. So let's say -1, 3, and then 2, 4, something like that. So slope, usually I draw like little arrows, kind of 4 minus 3. And you have to go 2, then you have to go 2 minus 1. Once you've said you're going 4 minus 3, you have to go 2 minus 1. You can't go -1 minus 2. It'll screw it up. So order, again, is very important here, as with all math. So 2 minus -1 is the same as 2 plus 1, which is 1/3. Okay, so it has a positive slope. The line must be going up. The line rises, right? Let's look at another one really quick. 6, -4, and then 4, -2. Okay, so again, I'm going to do my little arrows. -2 minus -4 all over 4 minus 6. Okay, so that'll be -2 plus 4 all over -2. And I'll end up being 2 over -2, which is -1. So that means this time the line is decreasing, or maybe the book will say falling. Okay, so the line falls. Okay. We want to then focus our efforts on creating equations of lines given certain bits of information. And in order to create these equations of lines, we kind of need point-slope form, and then we'll usually be transferring that into slope-intercept form, right? Okay, so first things first, what the heck is point-slope form? So point-slope form. Basically, you need a point and a slope. Okay, so given a slope and a point x1, y1, we'll call it. The equation is y minus y1 equals m times x minus x1. Okay, you'll need that memorized. You gotta have that memorized. Okay, so memorize this. Okay. And what the book is going to do is kind of give you some information, and you got to create the equation of a line. So find equation of line in slope-intercept form. And I'll define slope-intercept form here in a second, but for right now we just say this form. Okay, so the first kind of problem, they'll give you a slope and a point. Okay, so for example, slope is 4, the slope of the line is 4, and the line goes through the point 1, 3. Create the equation of the line. Okay, so this is x1, this is y1. And all we're doing is basically dumping this information into the point-slope form. So I'll have y minus y1, which is 3, equals m, which is 4, times x minus x1, which is 1. So I've got y minus 3 is, distribute the 4, so you get 4x minus 4. Okay. And then I'm going to add 3 to both sides. So plus 3, and I get it in that y equals mx plus b form. So y equals 4x minus 1. Sometimes, I don't think it happens in the homework, but sometimes they'll ask you to put your answer in different forms. And on the test, I'll tell you which form I want your answer in. If they don't say anything, usually they mean this mx plus b form. Okay. Let's try another one. Let's say they give you the slope is -1, and then the point is some fraction, -1/2, and then -2. Okay. So again, you're using the point-slope form y minus y1, -2, equals m times x minus x1. Okay, so y minus minus is plus. Here, -1 times x minus minus is plus. I like to clean stuff up. Just do one thing at a time. You start doing too many things, and well, when I start doing too many things in my head, I start making mistakes. Okay, so that's why I do it the way I do it. But anyways, distribute the -1. This 1/2, and then you can move the 2 over. So y is -x minus 1/2 minus 2. I need a common denominator, so I'm going to multiply this top and bottom by 2. Almost there. Y is -x minus 1/2 minus 4/2. So finally, y is -x minus 5/2. Okay, so that's the first kind of problem. The second kind of problem, what they do is actually give you some points, and then you have to determine the equation of the line. So let's look at the sky. Let's try, for example, -2, 0, and 0, 2. So you need two things. You need a slope and you need a point. You have 2 points, so that's good. For the slope, you're going to have to use the formula y2 minus y1, etc. Right? So y2 minus y1, 2 minus 0, x2 minus x1, 0 minus -2. 2 all over 2, so the slope is 1. Get some easy slopes to work with here. Then I'll go to my point-slope form. So y minus, and you could use either point, you'll get the same answer. I'll just take the first point. So y minus 0 equals 1 times x minus negative 2. Okay? So I get y is 1 times x plus 2, and then y is x plus 2. Okay? Let's look at another one like this. So we have negative 3 comma 6, and then 3, negative 2, and slope. Okay, so negative 2 minus 6 all over 3 minus negative 3. It's going to be negative 8 over 3 plus 3. Negative 8 over 6. Simplify your slope, so negative 4/3. Then go to your point slope form. So I'll just use the first point. So y minus 6 is negative 4/3 times x minus negative 3. Okay. And then clean it up. Okay. Then I'll distribute. Negative 4/3 x. So what is, negative 4/3 times 3? It's the same as times 3 over 1. The 3's will cancel. Negative 4. So it's just minus 4. Add 6 to both sides. It's negative 4/3 x plus 2. One more. So this time they're going to give us a point and the x-intercept. Okay, so they've actually given you 2 points just to disguise the second one as the x-intercept. So what is the x-intercept? So that's the place where it hits the x-axis. So it hits right here at negative 1. So that point is negative 1, 0. Okay, so we actually have 2 points, one negative 3, and then negative 1, 0. And we can proceed like we proceeded in the previous 2 problems. Right, so my slope, 0 minus negative 3, okay, all over negative 1 minus 1. And, if I'm going too fast, just pause the video and catch up. Or try to pause the video and see if you can do it on your own, and then check with my work. Okay. 0 minus 3 is positive 3. Negative 1 minus 1 is negative 2. So we get negative 3/2. And then you could pick either point. Usually the one with the 0 is easier to evaluate. So let's use that. Y minus 0 is negative 3/2 times x minus negative 1. So y is negative 3/2 times x plus 1, and then distribute the negative 3/2. Okay, so there we go. Let's hit that slope, this y equals mxb form now. And I hadn't really talked about it, but we've been using it, right? That's called slope-intercept form. Okay. Y equals mx plus b, where the m value, the thing in front of the x, is the slope, and then this b value is the y-intercept. Okay, so 0 comma b. Okay, if you're graphing these things, what you do is first plot the y-intercept, and then use the slope to get another point, and then connect the dots. Okay, so use slope to find the second point. And then connect the dots. Okay, so let's try, 1 or 2 of those. An example. Pen the work. Example. F of x equals negative 3x plus 2. So here the slope is negative 3. And if you want, you can rewrite it as a fraction. Just put it over 1. So down 3, right 1. Our y-intercept is going to be at 0, 2. And so we come over here to our graph, and we start at 0, 1, 2. Right? 1, 2, 3. And then we use the slope to get our next point. So it says down 3, 1, 2, 3, and then over 1. So it looks like that'll be our next point. So I went down 1, 2, 3, and then over 1. Okay, and you get like a triangle looking thing. And you should be going, it should be decreasing, right, as a negative slope. Let's do one more of those. Okay, negative 1/3 x. So this one, the slope is negative 1/3. Which you could always rewrite it with a negative, so you're going down 1 and then right 3, right? The Y-intercept. So this one always confuses people. Oh, hey, what's the Y? I don't know. It's 0, right? So you could just pretend it's plus 0, and so your Y-int would be 0, 0. Y-int, not ints. And that's your starting place. Right? So again, let's try drawing this. I start at 0, 0. Then I'm going to go down 1 and over 3. 1, 2, 3. And you kind of get that sort of triangle type deal there. And again, it's a decreasing line. Okay, so it'll look like that. Okay. Horizontal and vertical lines, we got to draw those characters every once in a while. And they take sort of a special kind of look to do these. So for the horizontal, you're only going to see one variable, right? And it's going to be the y variable. So you'll have some expression like y equals b. For the vertical, it's going to be an x expression. So you'll have something like x equals a. Okay, so let's look at an example. Y equals 4. So you could go literally to the graph, y equals 1, 2, 3, 4, and maybe you have it memorized that if it's in that form, it's a horizontal line. If you don't memorize it, the other thing you can do is kind of a T-table type deal, where y is always 4. So you could use any values for x. They say x varies over the real numbers. So you could say negative 1, 1, and maybe 2. You could use any x values, and then you could plot those. For example, negative 1, 4 is right here. You can use 0, 0, 4, I got it right there. 1, 4 is right here, and then 2, 4, is right here. So if you connected those dots, you would get that horizontal line. However you remember it, this example is a little different because it's kind of not set up in the traditional form. So what you need to do is put it in that form, x equals something. Okay, so I add the 18, 3x is 18, divide by 3, and x is 6. So you can literally, again, just go over and at 6, put a vertical line, or you can do a T-table again. And this time, x is always 6, and y varies over the real numbers. So we'll say, let's like negative 1, 0, 2, right? 6, negative 1, 6, 0, and then 6, 1, 2. So you get some points, and all you have to do then is to connect them. Oh yeah, lo and behold, it's a vertical line. Okay. Okay, so however you remember it, it's kind of remembering your left from your right, Anyways, let's move on to the last form that we'll look at, the general form equation of a line. And generally, it's given as ax plus by plus c equals 0, or they'll put the c on the other side in some books. Okay, so for graphing these things, you got two choices. You can rewrite it in the y equals mx plus b form, and then use the slope and the intercept. So let's try doing one of those. So for example, 2x plus 3y is negative 18. Right? Oh, whoops. 3x plus 2. Oh, geez, sorry. 2x plus 3y minus 18 is 0. Okay, so let's try that. So I want to isolate this y variable. Okay, so I move the 2x, move the 18. I'm going to get 3y equal negative 2x plus 18. Then I need to divide everything by 3. So y will be negative 2/3 x plus 18/3, which is really just 6, right? And then my slope, of course, is negative 2/3 down 2 over 3. And then my y-intercept is at 0, 6. Okay, so that's my starting place. 0, 1, 2, 3, 4, 5, 6. And then I go down 2 over 3. So 1, 2 over 1, 2, 3. Down 2 over 3. It's right there. And there's my line. Okay, so that's one method you could use. The other method you could use is plotting the x and y intercepts. So that comes down to just forming this table. For the x-intercept, you let y equal 0. And for the y-intercept, you let x equal 0. Okay, and then you kind of figure out the ordered pairs, right? So again, the x-intercept, you're letting y be 0. Okay, and let's make up a different example. Okay, and the y-intercept, you're basically letting x equal 0. Okay, so let's look at a different example now. This will be the last one we look at. 8x minus 2y plus 12 is 0. Okay. Right, so for the x-intercept, you let y be 0. So I'll have 8x minus 2 times 0 is 0, plus 12 is 0. So 8x is negative 12. And then x is negative 12/8, which is negative 3/2, I believe. Y-intercept then, you let x be 0. So you'll end up with 8 times 0 is 0, minus 2y plus 12 is 0. Minus 2y equals negative 12, and so y is 6. Okay, so you go over to your graph. 1, 2, 3, 4, 5, 6, 0 for the y-intercept. And then negative 1.5, negative 3/2 is negative 1.5, 0. And that'll look like this. Okay, so we have increasing function means positive slope. Okay, so can't underestimate the importance of slope in mathematics. Again, it's in the applications. It's in modeling the universe around us, so we can make predictions. So we can, if we do this, then this will happen. That sort of thing. Okay, and making predictions makes our world a lot nicer of a place. We know what's going to happen tomorrow. Wouldn't that be nice? So, okay, I'll let you go, and we'll see you next time.